Welcome to our comprehensive guide on JavaScript interview questions, covering essential concepts from front-end to back-end development. Today, we'll explore the core concepts that every JavaScript developer needs to master, including closures and scope, hoisting and context, prototypes and inheritance. We'll also dive into modern asynchronous JavaScript with promises and async await, ES6+ features, and Node.js fundamentals along with browser APIs. These topics form the foundation of full-stack JavaScript development and are frequently asked in technical interviews for both junior and senior positions. Let's start with one of JavaScript's most important concepts, closures and scope. A closure is a function that has access to variables from its outer scope, even after the outer function has finished executing. In our example, the outer function creates a variable called count and returns an inner function. This inner function can access and modify the count variable even after the outer function completes. This creates data persistence and encapsulation. Understanding scope is equally crucial. Var variables are function scoped and get hoisted to the top of their function, while let and const are block scoped and exist in a temporal dead zone until they're declared. This difference in behavior is a common source of interview questions. JavaScript uses prototypal inheritance, which is different from class-based inheritance in other languages. Every object in JavaScript has a prototype property that points to another object. When you create a constructor function like animal, you can add methods to its prototype property, and all instances will share those methods. This is memory efficient because the method exists only once on the prototype, not on every instance. The object.create method provides a cleaner way to set up inheritance by creating a new object with a specified prototype. Understanding the prototype chain is essential. When JavaScript looks for a property on an object, it first checks the object itself, then moves up the prototype chain until it finds the property or reaches null. Asynchronous programming is fundamental to JavaScript development. Promises represent a value that may be available now, in the future, or never. A promise has 3 states: pending, fulfilled, or rejected. You can chain promises using then and catch methods for handling success and error cases, respectively. However, async await provides a more readable syntax for working with promises. When you mark a function as async, it automatically returns a promise, and you can use the await keyword to pause execution until a promise resolves. This makes asynchronous code look and behave more like synchronous code, making it easier to read and debug. Always wrap await calls in try-catch blocks for proper error handling. Robust error handling is crucial for production applications. The try-catch finally block allows you to handle runtime errors gracefully. Code in the try block executes normally, but if an error occurs, execution jumps to the catch block where you can handle the error appropriately. The finally block always executes, regardless of whether an error occurred, making it perfect for cleanup operations. For global error handling, you can set up event listeners for uncaught exceptions and unhandled promise rejections. The window.owner handler catches JavaScript runtime errors, while the unhandled rejection event catches promise rejections that weren't handled with a catch block. These safety nets prevent your application from crashing unexpectedly. The Document Object Model, or DOM, represents the structure of HTML documents as a tree of objects that JavaScript can manipulate. Modern DOM selection uses query selector for single elements and query selector all for multiple elements. These methods accept CSS selectors, making them more flexible than older methods like getElementById. Once you have element references, you can modify their content using text content for plain text or innerHTML for HTML content. Be careful with innerHTML as it can introduce security vulnerabilities if you're inserting user-generated content. For styling, you can modify the style property directly or use class list methods like add, remove, and toggle to manage CSS classes efficiently. Event-driven programming allows your JavaScript code to respond to user interactions and browser events. The add-event-listener method is the modern way to attach event handlers to elements. It accepts 3 parameters: the event type like click or keydone, the handler function, and an optional options object. Unlike older methods, add-event-listener allows multiple listeners for the same event type on a single element. Event objects provide information about what happened, and you can call prevent default to stop the default browser behavior. Understanding event bubbling and capturing is important. Events typically bubble up from the target element to its parents, but you can control this behavior with the third parameter of add-event-listener. JavaScript's asynchronous nature is powered by the event loop mechanism. While callbacks were the original way to handle async operations, they can lead to callback hell with deeply nested functions. Promises provide a cleaner alternative with chainable then methods. The event loop determines the order of execution. Synchronous code runs first, then microtasks like resolved promises, and finally macrotasks like set timeout callbacks. Understanding this execution order is crucial for debugging timing-related issues. In our example, even though set timeout has 0 delay, it still gets queued as a macrotask and runs after the promise microtask, demonstrating the priority system of the event loop. Async await syntax makes asynchronous code much more readable and maintainable. When fetching data from APIs, you can write code that looks synchronous but operates asynchronously. The await keyword pauses function execution until the promise resolves, then returns the resolved value. For error handling, wrap await calls in try-catch blocks just like synchronous code. For parallel execution of multiple async operations, use promise dot all with an array of promises. This runs all operations concurrently and waits for all to complete, which is much faster than awaiting them sequentially. Destructuring assignment allows you to unpack the results into separate variables cleanly. Node.js brings JavaScript to the server side with a rich ecosystem of built-in modules. The module system allows you to organize code into reusable packages. CommonJS uses require and module.exports, while Ease6 modules use import and export statements. Node.js provides many built-in modules like FS for file system operations, Path for working with file paths, and HTTP for creating web servers. File system operations are typically asynchronous to avoid blocking the event loop. The FS.Promises API provides promise-based versions of file operations, which work seamlessly with async await syntax. Always handle errors when working with I/O operations, as file system errors are common in real applications. Error handling in Node.js follows specific patterns that differ from browser JavaScript. The error-first callback pattern is traditional in Node.js. The first parameter of callback functions is always reserved for errors, followed by success data. This convention makes error handling consistent across the Node ecosystem. For uncaught exceptions and unhandled promise rejections, Node provides process-level event handlers. These are safety nets that catch errors that slip through your application logic. However, when these handlers trigger, it's usually best to log the error and gracefully shut down the process, as the application state may be unpredictable. Proper error handling prevents server crashes and provides better user experiences. Let's summarize the essential concepts for JavaScript interview success. Master closures and the scope chain as they form the foundation of JavaScript's functional programming features. Understand prototype inheritance and how objects share properties and methods. Know how to handle hoisting edge cases, especially the differences between var, let, and const declarations. Implement proper error handling with try-catch blocks and global error handlers. Master asynchronous patterns, preferring modern async await syntax over callbacks for cleaner, more maintainable code. For interview success, practice live coding while explaining your thought process clearly. Discuss trade-offs between different approaches and always ask clarifying questions to show your problem-solving methodology. Remember that interviews test not just your coding skills, but also your ability to communicate technical concepts effectively.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.